So friends, are you searching for class 10 project on mathematics and you are not getting any idea of innovative projects that can give you 10 out of 10 marks, and when you are searching it on internet you are getting the results of a box in which when you match the correct answer the light glows out and you are bored of that idea, then you should try this clinometer. What is a clinometer? Clinometer is an instrument which is used to find the height of an object as well as the distance between the observer and the object. We are using various trigonometric ratios. Now, you would be thinking that how this clinometer is made. You don't need any expensive materials to make this clinometer. You are just going to need a thermocol, which you will keep as a base, then cover it with any colored chart paper or any colored fluorescent sheet you desire and decorate it. Then you're going to need this cylindrical cardboard roll. This I have taken from my foil paper roll, and then cover it with any colored chart paper or any colored fluorescent sheet. I have used the pink one, and then I took a cuboidal cardboard box and I have also covered it with the pink colored chart paper. You can use any of the color. And then I have made a design of a building on that cardboard box. As you can see that I have made a building design on this cardboard box. I will tell you later why I have made it. Then, to make the main part of this clinometer, this is the main part of this clinometer. You're going to need a protector. I think you all would be aware what is a protector. It is just a simple instrument which is used to measure the angle of any line segment. Okay. Then as you can see, I've pasted a straw on one of the end of this protector. Then I made a hole at the point from where you measure the angle, and I have pinned it with this cardboard roll with the help of an iron nail. And as you can see, a thread is hanging and an object is tied with this thread. I will tell you what is the use of this thread later on. Then, now how this clinometer works. Suppose you want to measure the height of this building. So that's why I have made it like a building, so that I can give you an example of the usage of clinometer. Like you want to measure the height of a building, that's why I made a building. So how to measure the height of the building? First of all, you have to find out the distance between the center of this clinometer to the building, and if you will measure the distance between the center of clinometer to the building, it will be 15 centimeter. That's why I have written 15 centimeter here. So the distance between the center of clinometer and the building is 15 centimeter. You can see that this clinometer is parallel to the building, so the distance 15 centimeter will always remain constant. 15 here, 15 here, 15 here, everywhere. So not everywhere, it's 15 here, 15 here, 15 here, 15 is constant. Now the next step you have to do is you have to draw an imaginary parallel line from the center of clinometer, which is parallel to the base, and you have to extend it to until it touches the building. And if you will do so, if you will make a parallel line from the imaginary parallel line from the center of this clinometer to the building, you will notice that it strikes the building at point A. That A, you can see, is the point where if we make a parallel line from the center of clinometer, it touches the building at this point. So the distance between the base of the building to the point A will also be the distance between the base of clinometer to the center of clinometer. How I can say that? as you can see that this clinometer is parallel to this building, and this center, the point from center to A is parallel to the ground, so it forms a parallelogram. Okay, and we know that the opposite sides of the parallelogram are always equal, so this distance is always equal to this distance. And when I measure the distance from the center of clinometer to the base, it comes out to be 19 centimeter. So the distance between the point A to the base of the building will also be 19 centimeter. I have told you the reason why. Then what you have to do is look through this straw and rotate the clinometer until you see the top of the building. And if you will do so, you will see that the thread is pointing out at 120 degree. I think you can see that. That's the use of the thread. It helps us to find out the angle. Okay, so if any observer will see through this straw the top of the building, the angle will come out to be 120 degree. Now, what is the use of this 120 degree? See, as you can see in this triangle ABC, this theta is the angle of elevation. Angle of elevation is that angle at which the observer see any point on object. For example, suppose at this point A you are standing, and this BC is Qutub Minar or the Statue of Liberty or Tokyo Tower, and this point C is the top of the Tokyo Tower or any of the monument you can take. And if you are standing here and you are looking at the top of this monument, then this angle will be known as the angle of elevation. So this is what angle of elevation. So to find out the angle of elevation, first you remember that when an observer saw through the straw to the top of building, the angle comes out to be 120 degree. Okay, the angle comes out to be 120 degree, but this is not the angle of elevation. To find out the angle of elevation, you have to subtract 90 degree from this 120 degree. I'll tell you the reason why. This is because, as you can see in this triangle, this 90 degree angle is fixed. So if you will add this 120 degree with 90 degree, the answer will come out to be 210 degree, which cannot be possible because an angle sum property of triangle says that the sum of interior angles of any triangle should always equal to 180 degree. So if it is coming out to be 210 degree, then this can't be possible. So we will subtract 90 degree from this angle. Okay, so if we will subtract 90 degree from 120 degree, the answer will come out to be 30 degree. So this 30 degree is the angle of elevation. So come to this figure. This theta is 30 degree, and we know the base. The base is this 15 centimeter, which is always constant. So now here in this triangle, this is a right angle triangle. This is also forming a right angle triangle. This is perpendicular to each other, and this is the hypotenuse. This is the hypotenuse. So this is also forming a right angle triangle. This angle was 30 degree, and this is base, and the base is 15 centimeter. First of all, you need to understand what is base and perpendicular. Okay, suppose this is the angle, then the side which is opposite to this angle is known as perpendicular, and the side adjacent to this angle is base. Suppose if the angle would be here, then the perpendicular would have been this AB, because this is the side which is opposite to this angle, and this would have been the base. The position of hypotenuse always remains constant because it is the wrong side. So the base is 15 centimeter and perpendicular we don't know, hypotenuse also we don't know. Now to find this height, we'll use the trigonometric ratio. We know that tan theta is equal to perpendicular upon base. If you are studying in class 10, then you would be aware of what is tan, what is cot, what is sine, what is cos. And if you are not, you will be told that what is tan theta, what is all that. So tan is perpendicular upon base. Here we don't know perpendicular, but we know what is base. Base is equal to 15 centimeter. So this theta is 30 degree. Okay, so tan 30 is equal to P by B. Here is 15. The value of tan 30 is 1 by root 3, and this P upon 15, and we will do cross multiplication. So 15 is equal to root 3p, and p is equal to 15 upon root 3, which is equal to 8.66 approximately. Now in order to know the height of the building, we will add this 8.66 with the distance from the base of the building to the point A, and we know that it was 19 centimeter. I told you it was calculated by using wide measurements, so it was 19. So 19 plus 8.66 is equal to 27.66 approximately. And you would be surprised to know that when I measure the height of the building by using my ruler, it comes out to be 27.15 centimeter. You don't need to worry if the answer is not exact to the real height, because this is due to the measurement issues while making this clinometer. So this is the use of clinometer. You can use this clinometer in various ways. Suppose to know that at which height that tube light is, or in any other applications. So friends, this was the end of the video. I hope that you have liked it. So don't forget to like this video. Bye bye.